this video we'll talk about evaluating a piecewise defined function. So what is a piecewise defined function? A piecewise defined function is a type of function where it has different definitions along different ranges or different spans of x values. Okay? Now remember, a function is we put in our domain, usually denoted by x, right? And we get out a range of values, or we get out our function values. So for this particular function, h of x, it equals -3, so our outputs are -3 if x is less than -2. So only if x is less than -2 is our output's going to be -3. Now it equals x if our inputs are between -2 and 4. And then our function outputs equal 5 if our inputs are greater than 4. So when it says to find h of -10, well, -10, that is an x value. That is an input. We're putting it into our function. And -10 happens to be within this domain. So we use this part of the function, and there's actually no function to put the value into, so it's just -3. What about h of 2? Well, h of 2, I'm actually going to do this in a different color here. h of 2. 2 is our input, right? Our input has to be within a range of values. So 2 is in between -2 and 4. So we use this part of the function. So I just plug in x, which is, the function is just x, so it's 2. Okay, what about h of 5? Well, our input is 5. 5 is more than 4, so it lies in that portion, that part of the domain. So it's just going to equal 5. Now what about if I was asked to find h of 4? Now 4 is at this break, right? So we have to be careful about it because we have to look at this equal to sign. 4 is only included in this portion of the domain. It's not included in here. If it was, it wouldn't actually be a function. Okay, so it's going to equal x. Our x value is 4, so the function at that point is 4. Okay, here's another problem, a little more involved here because we actually have function values. So let's take a look at f of 0. 0 is our input. Where does 0 lie here? Is 0 less than or equal to 3, or is 0 greater than 3? Well, 0 is less than or equal to 3, so we're going to use this function. What we do is we plug in 0 for x, that's our input. So we get 0 minus 1 is -1 squared minus 2. -1 squared is a positive 1. Minus 2 is -1. So f of 0 equals -1. This means on this function we have the point x0, y -1. Okay? In the next video we'll talk about graphing these, but that's just a little introduction there. Now what about f of 2? Well, f of 2 is 2 less than or equal to 3, or is 2 greater than 3? Well, 2 is less than or equal to 3, so again we're going to use that same function, that same piece. That's why it's called a piecewise function. So we're going to plug in 2 for x, so we get 2 minus 1 squared minus 2. 2 minus 1 is 1, squared minus 2, which is again 1 minus 2, which is a -1. So we also have the point x is 2, y is negative 1 on our graph. What about f of 3? Well, this one, f of 3, is right at that break. So we have to consider where is it equal to 3. It's equal to 3 on this one, so 3. If I plug in 3 here, 3 less than or equal to 3, that works. 3 is not greater than 3, so I have to use this one again. And I'll go 3 minus 1 squared minus 2. I'll eventually get 3 minus 1, which is 2 squared minus 2, so I'll get 2 here. So I have a 0.32. For the next one, f of 4, I want you to pause the video right now, try it on your own, see what you get. Okay, I'm going to continue. If you haven't done it on your own, please go ahead and pause the video. We're going to plug in 4 for x. Oh wait, I didn't do something. What did I not do? I didn't check the domain, right? The domain, I'm working with an x value of 4. 4 is not less than or equal to 3, so I can't use this first part. 4 is greater than 3, so it fits into this piece of the function, so I need to use that part of the function. So 2 times x, which is 4, that's our input, minus 1. So that's 8 minus 1, which is 7. So we also have the point 4, 7 somewhere on this graph. That's evaluating a piecewise defined function.